Alrighty, welcome back to 105. Thank you for joining me today. Today, we get to talk about arrays, which is going to be a lot nicer than talking about pointers that we talked about before. So this will be the first data structure we use, and this one will be a very useful one because it will save us a lot of work and a lot of repetition. So right now, we already have loops for dealing with repetition using code, but they don't help us with repetition using different data, different variables, multiple variables. So, for example, right now, if we want to calculate the average of a bunch of grades, our code looks a bit ugly. If we wanted to compute the average of, say, 5 different grades, well, if we wanted to put each grade in its own variable, we'd have to create 5 variables. We would have to come up with names for all of them. Right now, I could creatively say, hey, let's use grade 1, 2, 3, 4, and 5. And then to compute the average, well, the average is just adding all of the grades together and then dividing by the total number of grades, which is 5. And that will get me an average. So this, if I go ahead and run it, will get me an average of 78, but it's kind of cumbersome. It's error prone. I'm having to make up really lame names. So if I wanted to, add a new grade, add a new student, that means I have to add a new variable, which means I have to add it to that average calculation. I have to change the divisor. Typically, if I have to change code in more than one place, it's error prone. I might forget to change it in one of those 2 places, in which case my program will not behave as I expect it to, and it will either crash or produce wrong results. So, in order to be lazy and save us a bit of time, we can use something called arrays, and they are for groups of related values. So, what you can do instead of declaring 5 integers all in separate variables is you can declare a number of integers all at once. So the syntax for declaring arrays, again, syntax is just the rules of C, looks a lot like a variable declaration, but now we have these square brackets. So at the beginning, we have the type, like before. Int, char, double, or bool is what we know so far, and pointers to all those with the little asterisks. Then the name for the array, and then in square brackets, the array size. So again, you replace the type by the type, name by whatever you want to name it, and the array size by the number of values you want to create. So I can create a whole bunch of integers all in one go. So for instance, I could do something like, I don't know, call it grades and give it the size 5. And then after you've declared the array, you can access a single element. So that's just a fancy way of saying accessing a single value in that array, so in this case a single integer, by just using the square brackets again. So you give it the array name. The array name by itself refers to an array, which is its own special type. And if we want to get a value of it, we use square brackets and then this index, where the index is just a number. So that is the element number I would like to select, and it is an integer. And it always starts at 0. So everything is indexed at 0. Computers, again, like being indexed at 0, not 1 like humans. So just remember that it always starts at 0. So again, called an index because it starts counting at 0 in C's array, or in C, like in most programming languages, they are, in special parlance, 0 indexed. And that's true for most programming languages. So for instance, if I called the array A, if I did A square brackets 0, that is the first value, or generically we call it an element because it might hold something slightly different. And A at square bracket 1, that's the second value because, well, the first one's 0, the second one's 1. So it is different by 1 than what we're probably used to. But that is how computers speak. So we can change our code to use an array instead. So if I go back to it, instead of declaring int grade 1, int grade 2, int grade 3, int grade 4, int grade 5, I can now declare an array, and I could call the array grades. So in this case, they're integers still. My array is called grades, and I want 5 of them. So now if I were to assign the values, I could assign them like this. So grade 0, the first one is 75, then 83, 99, 64, then 72. And then for my average calculation, I can change grades to just access them by their index. So this should look closer to something we can actually simplify a bit. So if I didn't want to write grades 0, 1, 2, 3, 4, what should I replace this with? A loop, right? That looks loopy to me. So every time through, if I break that out into something that happens each time, well, if I had an int called I that was keeping track of the index, the first time through, I'm accessing 0, then 1, then 2, then 3, then 4. So I can actually use a loop instead of this. So I can create a new variable called sum, because first I'm going to break apart that summing of all of the grades all at once. So I could do something like for int equals 0, again, has to start at index 0. And then I is less than, in this case, 5. That's how many elements there are in my array. And then I can do, of course, plus plus I. And then inside of here, I could do sum plus equals grades I now, right? And then I can replace this whole thing I calculated in a loop by just sum divided by 5. So everyone okay with that? So now I'm making my code a bit. We'll do some more improvements, but now I'm kind of generalizing it more and more and more and more. And just as, I don't know, as a, I guess, review or question, how I wrote it is kind of correct. What about if I wrote it like this and just said, oh no, the average is just the sum, I'll just keep on calculating it. Will I get the same result if I do it this way instead? Yes? Same result? Anyone, any words to the contrary? All right, well, let's see. So we can compile, run it again. Our average just went down by 2. Yeah?
It doesn't work because if you divide the current sum, then it will just truncate because it's an int, but then if you divide it after, then you truncate the actual sum.
Yeah, so because this, remember, this is integer division in here. So if I have integer division at every step of the loop, remember that truncates, it will just cut off the decimal for every single calculation instead of just summing them all together and just doing the integer division at the very end, which would just truncate the final expected result, which would probably be closer to what you have. So that is why you have to be very careful with integer division. You pretty much just want to, if you're doing integer division, just leave the division until the very end, and that can be the last thing you do. So this is not the same as this, because again, if I do the integer division there, it will truncate it for every single term instead of just truncating it all at the end. So another quick review. So everyone get that thing, just as another word of caution of integer division, which is what makes programming fun. And there we go, our average just went up by 2 again. So you probably wouldn't like that if we did the other one to calculate your average grades. You'd probably be very angry at us and be like, what the hell are they doing? So everyone's all right? All right. So we still have a little bit of a problem. We have a magic number we want to get rid of. So I use the magic number 5 in multiple places, right? So if I wanted to add another grade, well, then I have to increase the size of the array to 6. Then remember to change the loop bound to 6 as well. And then remember to divide the average calculation to divide by 6 at the very end. So every time I want to add another grade, I have to remember to add it to 3 places, which is probably really bad. So one way I can get rid of it is I can use the C preprocessor. It will do basically a search and replace for me. So if we write our own hashtag define, it will look for this text. So it's what the preprocessor will search for before it gets to the compiler, and replace it by this replacement text. So that search should be a string. Usually use all caps separated with the word separated by underscores, and the replacement by what you would like written instead. So you can write defines like a function. They can have arguments and things like that, but you won't have to write any for yourself in this course. I'll show you one a bit later, but you just have to know what it is. People just generally copy and paste it and use it all the time. So let's go back. So if I wanted to get rid of my magic value, I could instead do hashtag define, call it something like grades length. And then anytime my compiler sees, or this preprocessor sees grades underscores length, it's just going to replace it by the number 5. So anytime I use that magic value 5, I should instead use, grades length. So grades length here, grades length here, and grades length here. So now if I want to add another element, it's super easy. I don't have to remember to change the same thing in 3 different places. I can just change that 5 to 6, and boom, I'm done. Yeah?
What's the difference between using define and defining a variable?
So what's the difference between using define and defining a variable? Like if I just did int grades length equal 5, and then just do it there?
Yeah.
In this case, nothing, because this is a newer version of C that will accept it. Older versions of C's, they will not let you use a variable to use the array length. So in older versions, you have to do that. I'll show you different ways to do it, but now you can use a variable. There's no difference other than that would be like a global variable, maybe. Yeah. And yeah, we could also do a global constant in newer versions of C. So I could do something like, in this case, I could do, I don't know, const int, static const int, grades length, and do that, and replace it here. And that will still work, again, in newer versions of C. That define is for older ones, but I'll show you a different way to do this as well. But everyone okay with that? So another good way, if you're repeating yourself, just create a variable so you don't have to remember to change things in 3 places. If you have to remember to change things in more than 2 places, you should probably rewrite your code so you don't have to do that anymore. So another thing I can do as a shorthand is I can assign values to elements in the declaration, like before when I could combine declaring a variable with assigning to it. I can do the same thing with an array. So the syntax for declaring and assigning values is a little bit different because I might be assigning multiple values based off how many elements are in my array. So like before, we have the type, the name, and the array size in square brackets for the declaration. And then instead of just equal a value, we have to give it multiple values because it's an array. So we just put it inside some curly brackets, and then it's just comma separated values. So the values you'd like to assign in order, they match the type of the array. So if I say it's 5 elements or something like that, then it has to actually match. And this actually might be one of the reasons why we actually have to use the define instead of a variable if we want to assign values to it. So let's just go ahead and check. So if instead I wanted to combine everything, so right now I have grades length as a constant int. I'm guessing this will not allow me to do something like this. So instead I could just do 75 83, 99, 64, 72 instead of all these variables. And assuming I have a newer version, it should let me compile this. Variable length array folded to a constant array as an extension. Okay, so that means something to me, probably not something to you. What that basically is telling you, if you use a variable, like grades length isn't just a plain number, it's a variable, so technically I could change it and the length of my array could change even though I said it's const. It's not quite that smart. So my compiler complains very loudly that it is doing some magic as an extension. Typically that means it won't always work on other machines. So if I want to not use a variable here and just use a number that the compiler can argue about, then in that case, that's why I would just use the define. So if I define grades length as 5, then everything is all happy because it's essentially, by the time it gets to the compiler, it's the same thing as if I just wrote this. It will do a simple find and replace before it gets to the compiler, so it knows the size of the array, how many elements are there. While if it's a variable, it won't quite know the size of the array, so let's just make C happy and do this. Yeah?
Can you redefine grade length?
So can I redefine it? If it's a define, no. It's just the same. It runs once before it compiles, the compiler compiles it, and then it's in there. So that's why I can argue about the size of it, because otherwise, if you let's say I try and assign another value here. So like, let's say someone did not do well. So I assigned 6 values to it, but my grades array is length 5. Well, bad things are going to happen. So it's going to say access elements in array initializer. So I tried to assign more elements than my array can hold, which means bad things will happen. In this case, this probably should be an error, not a warning, because very, very strange things will happen, which I'll show you towards the end, because it gets very, very confusing. So basically, don't lie. Everything should be in bounds, and because it's C, it doesn't really check for you. It allows you to blow your feet off if you want. So any other questions for that? So we're just assigning values to it right now. Okay, so as some warning, so you cannot reassign the array itself. You will get a compiler warning or a compiler error. So grades is technically a variable. Its type is it's an array. If I do something silly like say grades equals to 0, I will get a compiler error, because if I compile this, it will tell me that array type, so the type is an int array of 5, and the rule is you are not allowed to assign arrays. So they just exist. You're allowed to use them, access elements. You're not allowed to reassign them. So the error says array type is not assignable. In plain English, it's telling you you are not allowed to assign an array to another array or another value or do any assignment of an array. An array is an array, and you can't do anything about that. So that's just so you see that error. Yeah?
So let's say you didn't initialize the array. Would it have all zeros or would it have garbage values?
Yeah, so that's a good question. If I didn't initialize the array, will it have all zeros or will it have garbage values? And the answer to that is it will have undefined values, but sometimes it will be 0. Probably on all your systems it will be 0, but see if I just do this right now, let's see if I just define it and then sum it, so I didn't initialize anything and I just run it, it's just going to be uninitialized. It's going to be some giant value, probably some giant negative value, and if I sum them, it probably won't make any sense. Yeah?
Wait, so are you allowed to do, like in grades, is an int array with 5 elements? If you have another array with 5 elements, can you not assign grades to that element?
Yeah, so the question is, if I have two arrays of the same size, can I not assign them to each other? And the answer to that is no, you are not allowed to assign arrays whatsoever. So even if I did, I don't know, int test grades length, if I did something like test equals grades, something like that, still won't let me. It says array type is not assignable. Doesn't matter if the types match or anything like that. Just not allowed to assign to arrays. C doesn't know quite know what to make of that, and as we go through, we'll find out the reason why, but it has to do with pointers, so maybe we won't answer it in this lecture, but we should eventually be able to answer it. All right, so everyone okay there so far? All right, so we could also just assign values and let C figure out the length of things. So turns out that I could have just done this. I could have just got rid of, I could have just got rid of the length inside of the square values. And then C will figure out the length for me, like how many elements I'm assigning. So if I add another one, it'll just make sure it can hold 6 elements, so on and so forth. So it will always create an array equal to the number of values. But now we might get in the case where, hey, if I add a value here, if I add another value, so let's say 44, then I also have to remember to update this grades length, right? Which isn't the best. So let's see what we can do with that. So again, just so you have it, I can just write empty square brackets. C will figure out the length for me based off how many values I'm initializing. So in this case where I assign 5 values, it will create an int array of size 5. So I'll show you some fun things we can do to actually figure out the length. So we have to talk a little bit more about memory. So an array is large enough in memory to hold all the values. So if I have, int grades square brackets, so I let C figure it out, and I assign 5 int values, well, that grades array will be able to hold 5 int values. We know the size of an int is 4 bytes, so the total size of the array is just 4 bytes times however many ints there are. So it's 4 times 5. So the total size of the array is going to be 20 bytes. Everyone okay with that calculation? Don't have too hard, math isn't that hard in this course. So remember we had that size of operator way back when. So I can actually make sure that it's right, and size typically relates to the size in bytes of something, not how many ints there are. So might be confusing at first, but whenever you see size, size typically refers to the number of bytes. So if I use size of grades, it will return me the number 20, because again, 5 ints, each int is 4 bytes. So again, here's a beware. Programmers sometimes get lazy. We are a lazy bunch of people. We sometimes use the terms length and size interchangeably. Usually we don't need the size in bytes of an array, only, when we're arguing about how much memory it takes up. So you might hear people say the size of the array in the previous example is 5, even though that's different than what's returned than the size of operator. So for consistency, you can yell at me if I'm inconsistent. I will try to be consistent, and whenever I say size, I mean size in bytes. Whenever I say length, I mean number of elements, so how many things there are in an array. So you should always try and be consistent, especially when you are first starting. Length is just how many things are in there. Size is how many bytes it is, and hopefully you don't have to use the size very often. So this is one of the defines that will actually calculate the length of the array for you, not the size of the array. And it takes an argument, and we call this a macro. So you do not have to know how to read this. You can just refer to it on the slide. If you're using an arrays before, just do an old copy pasta on this, and just feel free to reuse it. So what this does is basically define a macro called array_length that takes an argument, kind of like a function called array, and it will return how many elements are in the array, or what the length of the array is. And what it does, again, you don't have to understand this, just in case you're interested, it takes the size of the entire array. So in the previous example, that would be 20 bytes, and then divides it by the size of the first element, which would be whatever the type of the first element is. So this would be divided by the size of an int in the case of our int array. So if we have 5 elements are there, the size of our array is 20, and then it's divided by the size of an int, which is 4. So it would return that the length of the array is 5. So again, if I just did array length grades, it's equal to 5. So I can just use this. Then I can get rid of that grades length define I had. And if I want to add an element, I just add an element. Let's see, figure out the new length. Yeah? Yeah, so the question is, what's the difference between this and creating a function that does the same thing? So the answer is this will run before the compiler runs. So this just replaces this in your code. It saves you from writing this in your code. It's just a way to write code for you that you don't really want to write. So it's a way to transform code instead of compile it. So
You still have to call it, right? Like if you want to get the size.
yeah, you still have to use it. So like before, so if I just do define grades length 5, what actually happens is by the time my compiler sees all my code and compiles it, it's as if I didn't actually write this at all. So it does a search and replace. It'll get rid of this and replace any time it sees grades length, it will replace it by 5. And then same thing for this. It's a little more complicated. Each time it says array length and then you put something in brackets, it'll just replace that array length by the size of array divided by size of array at index 0. Yeah?
So a function was like actually run here.
Yeah, so a function will be compiled and actually run when you execute your program. Yeah, this is just run while you're compiling before your code actually compiles. Yeah.
So you do array length, and then in the brackets, is that the array name?
Yeah, in the brackets is the array name.
That's where you put in length.
Yeah, so that's where I put in grades. Yeah, yep,
So you have an array, right?
yep.
And I'm just wondering because like here, like we can make the assumption that every data type in the array is an int or a float or whatever. Are there any data structures in C where, like, you know, in an array, some part is int, some part is char, some part is floats, or is it all OC?
Yeah, so the question is, if I have an array in C, is it possible that each element is a different type? Like the first one's an int, the next one's a char, so on and so forth. And the answer to that is no. So in C, your array elements all have to be the same type. If you want that, if you want all different types, you have to make up your own thing. So you could make it, in that case, you'd have to make up your own data type. Probably it would be a void star, it would be a pointer to something, and then some information that tells you what it actually is pointing to. And you have to figure it out, and it gets really messy. And then that's why people invented Python. So Python is good for some things. It's just ridiculously slow, but we like going fast, so we have the bare minimum here. All right, so now I can get rid of all of the magic values. So again, here's just that example to the size of bytes, so that would be 20. You just close that. So here is my final code where I don't have any magic values I have to deal with. So I have that define of array length. Again, you would just copy and paste it and just use it in your code. So here I do int grades with empty square brackets. Again, I just let C figure out the length for me. And then I use my macro called array length, so I don't have to, figure out, count myself how many elements are there. I just want it auto-calculated for me. So I just do array length grades, and then that will give me the length of the array, or how many values are in this array. I call it grades length. I put a variable, and then I can change my rest of my code. So I sum, go over grades length. Again, like before, sum it up. do the average all at the end. It's again to that variable. Everything is hunky-dory. Now, this is fantastic because now if I want to add another grade, I don't have to remember diddly squat, right? I just add another grade. Let's say someone just got 100 because we listened to this lecture. Boom, C figures out how the new size of that array is now 6. This array length macro will use that size, figure out the length is now 6. It'll be assigned to grades length. It'll be used for my loop bound. It'll be used for my average. Everything will be great. And because we took this lecture, our average increases from 78 to 82, which is hopefully what will happen by the time the course grades get calculated, right? All right, any questions about that? That is the good version. Again, should try, again, if you're coding and you need to change something, you have to change something in multiple spots, it will be error prone. You will forget one time. You will debug it maybe for an hour, maybe 2. Maybe you need a good night's sleep. Who knows? Just try and eliminate that if at all possible. So, if you don't listen to me and you try and access things willy-nilly, then you need to ensure all your array indices are valid. So again, assuming I have this integer array called grades, and I have 5 values in it, so 5 elements, that means I can only access grades at index 0, 1, 2, 3, 4, because those are the only ones that are valid. -1 doesn't make sense. 5 doesn't make sense because it's too small, but C doesn't care. C will let you do that and bad things will happen. So it is up to you to make sure you index things properly. So in general, if you have an array with a length, call it array length, you can only access element 0 up to array length -1, right? Because it's 0 indexed, you can't access array length. That would be beyond the scope. It's always 0 up to array length -1. So very, very, very odd things might happen if you have screwed up. So let's see. So here's my example. So all I did, so at the beginning, int x equals 1. Everyone knows what that does, right? Declares a variable called x equal to 1. Then I have an array of grades. It is just auto-sized by C. There are 5 elements in there, so the length of it is 5. So the grades length is 5. Again, if I calculate the average, I go through. Oh, okay, well, I go down less than grades length, so this will run for I equals 0 up until grades length -1 because it's less than. Sum everything, so all these array indexes are going to be valid. This is no problem, it's just dividing something, it's average. And then maybe later on my code I screw up and do grades at index 6 equals 2. There's a little squiggly line under there. If I compile it, let's see. Oops. So if I compile that, my compiler will say, in this case, because I used a hard-coded value, like I used a literal value here, the C compiler is not that dumb. It's smart enough to say array index 6 is past the end of the array, so it's basically saying you are not allowed to access this because, well, you're accessing element 6 and the array is only of size 5. If I wanted to get rid of that warning, it's not hard. I could do something like int I equals, or just confuse it. Int I equals, what is it? So it comes down here. Int I equals 6. So if I just do that, it means the same thing, but now my compiler won't even help me, right? So now, because it's in a variable, the compiler can't reason about it even though it should, and it's not going to warn me or do anything, but this is bad, right? Well, this should be bad. Why is it bad? Well, let's print off the value of x. So if I run this program, right, what should the last line print? What is the value of x at the end? 1, right? 1. Starts off at 1. Do I ever reassign it? No, so it should be 1. So if I run this program called out of bounds, x is 2. I see confused faces. That's good, because going past the bounds of an array is called undefined behavior. And a whole whack of things will go very, very wrong, and it will make your debugging experience very, very confusing. So the reason this happens is because it just so happens that on my particular computer, probably yours too, wherever this x is stored in memory, it's stored right after the array. And if I access array at element 6 here, that's outside of the bounds of the array, right? So the valid indices should be 0 to 4. It'd be 5 integers all in a row. Well, turns out x lives just a few bytes over. So grades at index 6 just so happens on my machine to refer to the value of x because, well, it's not in the array. So C says, I don't know, something could happen. Turns out on my machine that just happens to be where x lives. So if I change this, it's actually changing the value of x. So compile it, run it again. It changes to that value because, yeah, bad things have happened. Yeah.
How do you like append or add to a list?
How do I append to a list? We do not know what a list is yet.
Oh, sorry, I meant like an array.
How do you append to an array? There are ways to do that. You cannot append to an array just defined in a function. As soon as you give it a size, that's its size until it's done. So if you want to make the array bigger, we will get into how to do that later, but we have to do that dynamically because we might not know how many elements we need to get to use for memory. All right, any other questions aside from this being really confusing and you shouldn't do it? Yeah?
So technically we just got lucky in this case, right? Because like the x is like stored right next to array, or like it is unfair in every certain case.
Yeah, I got lucky or perhaps unlucky in this case, depending on how you define it. That just so happened to work. I could get very unlucky. Let's see. There's going to be one value where I'm going to get super unlucky. I forget what it is. So if I do this, that still works. If I do, there will probably be a magic number that causes really bad things to happen. Yeah, probably not going to find it now. But basically, we just got super unlucky. Or lucky, depending on how you do that. This is still changing random memory. It's just not changing in a way that happens to affect my program right now, but sometimes it might. Yeah?
What if I was negative?
Well, if I is negative, yeah, so that's another good question. If I is negative, C doesn't really care. It'll let us do that, let us run. No problem. It's, again, undefined behavior because it's accessing random memory. But C doesn't stop us from doing diddly squat. Let's see if -2 is that bad. No. But there are some values that will cause really, really bad things to happen. Again, I might have some time to show you some tools to try and detect this stuff if this is going on, because this is a pain to debug because sometimes there's definitely an issue here, but sometimes I can't see it. It runs normally. I might not actually see the error until you submit it to the grading, and then it doesn't work, and then you're like, oh, the grader's bugged. No, it's not. It's your code that's bugged. Sometimes people like blaming the compiler for things. It's not the compiler. Compiler's been the source of one issue I've had across 20 years of programming, so it's probably not the compiler. It's probably your code. So it's just a warning. Don't do that. So just so you have on the slides, again, odd things might happen. Some computers grade 6 will reassign X. So I saw X is 2 printed. Again, very confusing. Anything I put in bold and red means you should write it like 1,000 times and just follow that word of advice. So always make sure your array indices are in bounds. So C, the whole goal of C is to be fast. Some languages will check if things are inbound for you, but C doesn't do that because that's slow. So if you want to do that, you would have to write it yourself. So you could write your own bound checks if you want, but again, that will just make your program a bit slower, but probably better for detecting bugs and things like that. Again, up to you. All right, any other questions before we wrap up a bit early and rejoice? Yep.
What was the one issue that you had with the compiler?
Oh, what was the one issue I had with the compiler? I forget. It miscompiled something, or it just, I forget what happened. Something really weird happened. All right, no questions? Sweet, I will stick around then just in case, and remember, pulling for you, we're all in this together.